Assalamualaikum and hi SPM students. Welcome back to Tutoring ChemPhy. Physics Form 5 Chapter 1, Resolution and Equilibrium of Forces. Leraian daya dan keseimbangan daya. So hari ini kita akan belajar dua subtopik Physics Form 5 Chapter 1. So let's start with the first subtopic, Resolution of Forces. Leraian daya. So when it comes to resolution of forces, all students need to know that we want to resolve a force into two component. Leraian daya ni, apa maksud dia adalah kita nak leraikan satu daya ke dua komponen utama. Komponen pertama adalah Fx, daya di bahagian komponen mengufuk. Komponen kedua adalah Fy, daya menegak. Your Fx is your horizontal component, your Fy is your vertical component. So this one, you need to know what is Fx for, what does Fy do. So for Fx, you need to know Fx is used for object to move forward atau backward. So you guys ada daya Fx. Fx ni lah yang berperanan untuk objek tu gerak ke depan atau gerak ke belakang. Make sense lah sebab your Fx dekat part Cx, your horizontal component. So you guys boleh gerak ke kanan, ke kiri atau ke depan, ke belakang. Your Fy is for object to be lifted upward or downward. Daya Fy ni adalah untuk objek bergerak ke atas atau bergerak ke bawah. So, resolution of forces, we have our formula. For Fx, it is F cos theta. For Fy, is equal to F sin theta. Make sure your theta is from Fx to your F. This is our Fx, this is our F. Theta is located here, between this Fx and F. So, next thing is our slope surface, permukaan condong, satah condong. So, dekat permukaan condong, you guys akan ada objek yang mempunyai berat. The weight of the object can be resolved. Kita akan leraikan juga berat objek tu kepada W parallel ataupun Wx atau W perpendicular, Wy. So again, both Wx and Wy, we have the formula. Wx is equal to W sin theta, which is W parallel. W perpendicular, your Wy is equal to W cos theta. Again, make sure your theta is located at the edge of the surface, dekat hujung bucu permukaan. Okay, so this one, you need to know that our Wx is actually berat selari dengan permukaan condong, which is this direction. Selari dengan permukaan condong. Your Wx will cause the object to move downward. This is very important. Wx tu yang membuatkan objek menuruni permukaan condong. Wy, your W perpendicular, is actually a force perpendicular to the slope surface. Daya W, your berat, yang berserenjang dengan permukaan condong. So that is what we will learn in resolution of forces. Next thing is equilibrium of forces, keseimbangan daya. Whenever you guys see this keyword, you guys kena relate dengan keseimbangan daya. The first keyword is stationary or at rest. Satu objek dekat keadaan pegun atau dalam keadaan rehat. The next thing you need to know, the next keyword is uniform or constant velocity. Objek yang sedang bergerak dalam halaju mala atau halaju tetap. And the next keyword is when you have an object that is hanging stationary in the air. Kita ada objek yang tergantung dalam keadaan pegun. So whenever you guys see these three keywords, you guys must have the strategy to solve the question given. So this is the strategy that you guys need to know. The first strategy for equilibrium of forces. Nampak je soalan keseimbangan daya, you guys boleh apply segitiga daya. Segitiga daya kita akan pakai petua sinus atau petua cosinus, sine rule or cosine rule. Atau kalau you guys tak nak guna segitiga daya, you guys can apply this concept. Your Fx equal to 0, your Fy will also equal to 0. Fx dengan Fy ni is a force that we have already resolved. Daya yang kita dah leraikan, and then you guys akan total sama dengan kosong. Nanti kita akan tengok soalan yang apply equilibrium of forces dengan leraian daya. So you guys must know that these two forces, these two subtopics are actually related to each other. Resolution of forces and equilibrium of forces. You guys must really understand the concept first, and then you guys must go through some questions to improve your understanding. Okay, so let us do some question to improve our understanding. The first question, diagram shows a box being pulled by a boy. So you guys can see there is a boy pulling a 4 kilogram of box with force 30 Newton. Okay, so the question asks what is the acceleration of the box? Kita nak cari pecutan kotak tersebut. So, kalau you guys nampak gambar macam ni, you guys know that the force 30 Newton can be resolved into Fy and Fx. Sebab tu kita belajar leraian daya. Sebab daya 30 Newton kita boleh leraikan kepada Fy, which is this one. Dan kita leraikan daya yang sama kepada Fx, which is to this direction. So, you guys know what causes the box to move is because of our Fx. Fx will cause the box to move to the right or to the left. In this situation, it will move to the right. So Fx equal to F cos theta. With our theta must be between Fx and F, which is our 60 Newton. So you know our Fx will be 30 cos 60. So we will got our Fx, which is equal to 15 Newton. Fx is what caused the object to move to the right. That will pull this box to the right. But if you look closer, we have 5 Newton of force with direction opposite to the Fx. This is your frictional force, daya geseran. Kita ada daya 5 Newton yang menentang Fx. Kalau ikutkan Fx nak tarik kotak ke kanan. Tapi masa yang sama kita ada Fy. Kita ada frictional force, kita ada daya geseran yang menentang pergerakan Fx. So, our net force, resultant force, your F, akan jadi Fx tolak Fr, your daya geseran. Fx is your 15 Newton, tolak daya geseran 5 Newton. So your resultant force, daya paduan, daya yang bersih, you guys dah tolak semua geseran, you will got 10 Newton of force. So soalan minta acceleration, you know F equal to ma, your F is 10, m is 4 kilogram and a, therefore you will got a equal to 2.5. Unit is meter per second square. So our answer will be A. So you guys must master how to resolve a force and how to use the formula Fx equal to F cos theta, F equal to ma. Be careful of that. Second question, diagram shows a toy car of mass 0.8 kilogram which is released from rest and is now moving down a smooth inclined plane. The inclined plane makes an angle of 50 degree with the horizontal plane. So you guys, ada satu permukaan condong dan kita ada satu kereta mainan G-SIM 0.8 kg. So kita ada sudut antara permukaan condong dan permukaan rata adalah 50 degree. So soalan tanya what is the acceleration? Sama juga nak cari pecutan experienced by the toy car. So dekat slope surface, dekat permukaan condong, tadi kita dah pergi, our Wx, which is berat parallel, weight parallel to the surface, is what caused the object to move downward. So kita ada objek yang menuruni permukaan condong. Kenapa? Sebab adanya Wx. So dalam situasi ni, kereta mainan akan turun permukaan sebab ada Wx. So your Wx is equal to W sin theta. So W is 0.8 times 10. This is your berat. Times sin theta. Your theta is 50. Therefore, you will get Wx equal to 6.13. Make sure unit is Newton. So, this 6.93, daya 6.13 Newton ni lah yang membuatkan kereta mainan turun permukaan. This is your Wx. Soalan minta pecutan, acceleration. You know that Wx is also a force, is also F. So, Wx is equal to F, which is also equal to ma. 6.13 Newton equal to 0.8 a. Therefore, you can find our a, acceleration, which is 6.13 divided by 0.8. So we will got 7 7.66 meter per second square. So you see, we understand the concept first and then you just substitute with the formula. So we will got our answer D, 7.66 meter per second square. Next question. Diagram shows two forces, 5 Newton and 4 Newton, act at a point and make an angle of 60 degrees with each other. What is the resultant force? Okay, this one is like very famous question. Kalau you guys tengok buku teks atau buku latihan atau buku rujukan, akan ada daya yang kita kata non-parallel forces. Daya ni tak selari like this one dalam gambar ni. So as you guys can see, we got two forces. 5 Newton, the first force, and the second force is 4 Newton. So using our common sense, secara common sense-nya, daya paduan resultant force yang terhasil mestilah arah ke sini. Sebab you guys ada satu yang tarik ke sana, satu lagi daya tarik ke sini, so your resultant force akan arah ke sini. So macam mana nak selesaikan soalan ni? So you guys akan pakai cosinus rule. Cosine rule kalau you guys tak nak pakai parallelogram method. So in case soalan ni keluar dekat paper 1, you guys can just use cosine rule, petua cosinus. So macam mana nak pakai petua cosinus? So kalau you guys panjangkan daya 5 Newton ke sini, and then daya 4 Newton ni, you guys bawa ke hujung daya 5 Newton, this one. Okay, so you guys tahu sini pun akan jadi 60 degree. So dekat sini 180 tolak 60, you guys know it is 120 degree. And you guys also know our daya paduan resultant force is this one. This is your resultant force. So kalau you guys perasan, kita ada satu segitiga like this one. This is 120 degree. This is 5 Newton. This is 4 Newton. And this is your daya paduan, resultant force. So you guys ada dua sisi yang sama and you got one angle. This one you've learned. So cosine rule will be F square equal to 5 square plus 4 square minus 2 times 5 times 4 times cos 120. So you will got F square equal to 61. Therefore, your F, your resultant force, daya paduan, will be square root of 61, 7.81 Newton. Because it is a force, so your resultant force will be 7.81. Our answer will be C. Okay, this one is like very famous question. So you guys can apply whether parallelogram method or triangle method, or to be faster, you guys can apply this cosine rule. Make sure you understand the concept first. Next question. A car with a mass 880 kg is moving on the road with constant velocity. So we got our keyword here. Kita ada keyword halaju mala. So we know it is in keseimbangan daya, equilibrium of forces. The force exerted by the engine is 1600 Newton. Daya oleh engine tu yang membuatkan kereta gerak ke depan, that will cause the car to move forward, which is 1600 Newton. So question A. What is the frictional force, daya geseran, between the road and the car? So you know we got the forward thrust produced by the engine, which is F equal to 1600 Newton. At the same time, you got a frictional force, daya geseran yang menentang direction daya tujah engine tadi. This is your frictional force, daya geseran, which is what the question asks. So you know our keyword is constant velocity, halaju mala. So it is in equilibrium state, dalam keseimbangan daya. So keseimbangan daya ni maksud dia your forward thrust produced by your engine will actually be equal to daya geseran, frictional force. Therefore, your frictional force is equal to 1600 Newton. Why? Because it is in equilibrium state, constant velocity is actually halaju mala. So you know your daya tujah yang disebabkan oleh engine sama dengan daya geseran. That's why it is moving in halaju mala. That's why it is in equilibrium state. So question B, the question asks, calculate the acceleration pecutan of the car if the force exerted by the engine is 5,000 Newton. So you know F by engine is actually equal to 5,000 Newton since the question gives us that. And F frictional force, daya geseran, is still the same, 1,600 Newton. Why it is the same? Because it is on the same road, sama jenis permukaan, jalan raya yang sama, daya geseran yang sama. So you know, daya tujah oleh enjin 5,000 Newton, daya geseran yang menentang pergerakan daya tujah adalah 1,600 Newton. So kita boleh cari daya paduan. We can find our resultant force equal to daya tujah, your engine thrust, minus frictional force. So F equal to 3,400 Newton. So you know F equal to MA, right? Daya tujah equal to MA. So 3,400, your F, equal to your M is 880 kilogram. A. Therefore, your A will be 3,400 divided by 880. So you will get 3.86 unit in meter per second square. This is your pecutan apabila daya tujah 5,000 Newton tapi pada masa yang sama ada daya geseran 1,600. You guys cari daya paduan, you guys bahagi dengan mass supaya dapat acceleration. Okay, our last question. Diagram 13 shows a weight hanging on the string. Kita ada satu pemberat digantung pada dua utas tali. So, soalan minta determine the value of T1. This is your T1. If T2 equal to 25 Newton. T2 is 25 Newton. So, as you guys can see, our keyword is digantung, hanging. So, you know when it comes to hanging, it means the forces involved are in equilibrium state. Kita ada keadaan daya-daya dalam keseimbangan. So whether you guys can solve it using triangle of force, or you guys want to use Fx equal to 0 or Fy equal to 0. To be faster, let us use Fx or Fy equal to 0. So to use this concept, you guys must resolve every single force. You guys kena leraikan semua daya yang terlibat. So let us resolve all the forces involved. So for T1, the direction is here. So you know to resolve T1 will be like this. This is Fx, this is Fy. So for T1, Fx will be equal to F cos theta. F is your T1. Cos theta is 35 degree because your theta will be here. For Fy of T1, it will be F sin theta, T1 sin 35. So let us resolve next our T2. T2, our F is already given 25 Newton. So to resolve T2, it will be like this is the Fy, this is the Fx. And this is the 60 diagram. So for Fx of T2, Fx will be equal to F cos theta. F is 25. Cos 60. Fy is F sin theta. F is 25 sin 60. So another force that need to be resolved. Daya seterusnya yang kita akan resolve adalah berat objek ni. Kita tahu berat adalah mass darab gravitational acceleration. G is 9.81. So your W is actually equal to 29.43 Newton. W equal to 29.43 Newton. For W, if you want to resolve it, it actually only have Fy. Sebab arah kita memang betul-betul ke bawah. The direction is actually really straight to the downward direction. So for W, Fx, we have no Fx at all. So Fx equal to 0. Why? Sebab arah W itu sendiri memang straight to the direction ke bawah, to the Fy. So your Fy will be equal to your W, mg, which is 29.43. So selepas dah resolve setiap satu daya, baru kita apply fx atau fy equal to 0. Let's say I want to use fy equal to 0. This fy equal to 0 means all the fy that you've resolved, you plus together and equal to 0. Fy for T1 is T1 sine 35. This is Fy for T2 plus 25 sine 60. Fy for W is 29.43 Newton. But since the direction is to the downward direction, so you guys will minus 29.43. And then after you total everything equal to 0, so you will got 31 sine 35 equal to 7.78. So you got T1 sine 35 equal to 7.78. So to get T1, which is what the question asks, you guys will use 7.78 divide by sine 35. So you will get T1 equal to 13.56 Newton. Remember, for equilibrium state, you guys can either use triangular of force or Fx equal to Fy, Fx or Fy equal to 0. To use Fx equal to 0 or Fy equal to 0, you must make sure you resolve all the forces and then you total up everything equal to 0. When you want to total up everything, make sure you be careful with symbol plus or minus. That's all.